This webinar is presented by Kevin Thomas and Gerald Verbeek. This will be presented by Kevin Thomas, our construction sales and rental person, and our technical advisor, Gerald Verbeek, and Troy Chips.
This webinar is really a discussion between Kevin and myself. Kevin shared some questions with me that I've seen in advance, and that's why you will see on the screen in a few minutes. And then I will give some answers to that he hasn't seen yet, and have some discussions. And with that, Kevin, tell me what your first question is.
All right, so I come from a environmental geotechnical water well background initially, and I understand the process in the past. You'd go out and you would do geotechnical investigation borings for a potential construction site. So my first question was, how can CPT work in relation to the geotechnical borings?
Yeah, obviously, especially here in North America, a question that comes up an awful lot, because most of the time people are familiar with geotechnical borings, and CPT is new to them. And then you always want to know how this supposedly new method compares to what you're used to. And what I would put as answers are really summarized in these 6 bullet points. First of all, geotechnical borings, potentially combined with SPT, as well as CPT, are both geotechnical site investigation methods. So from that point of view, they're similar. They give you information about the soil at your job site. The big difference is that when you deal with geotechnical borings, you will have samples. You have something to touch. Where CPT pushes a cone in the ground, and you get all kinds of data on the soil, but you don't necessarily have to touch the soil. So from that point of view, they're different. You don't bring anything to the surface, you just measure in situ. Which also means that when you look at the overall schedule and the time frame that it takes, CPT is a lot faster. You push the cone in the ground, say that you go down to about 60 feet or so, about 30 meters, and you do that at a certain speed. Within minutes, definitely less than half an hour, you will have the results. You have all the information that you need, and potentially you could already issue the report to your client. Whereas when you deal with geotechnical borings, you need to bring the borings to the surface. Then at the end of the day, when you're going back to the office, you drop them off at the lab, and if you're lucky, the following week they will start giving you some results, but it could be even a few weeks before you get those results. So that means that the time frame is substantially different, and it's also different in that the person who is at the job site for a CPT, he will push the cone, he will take all the measurements, and can potentially already issue the report. So there's no phased execution. Everything is done at the job site, which means that if you are there and the operator, CPT operator, were to send the information to the person in the office who has to work with the data, you can immediately take corrective action. If there's some additional information that is required, you can do that because there's no phased execution. You won't get the results after the person has left the job site. Everything is done at the job site. As I mentioned before, there are no cuttings, no spoils. So especially in places where there's some environmental issues, some potential contamination, you don't have any problems because everything stays in the soil. The drawback or limitation is that you have no samples. So if you feel that you really want to make sure that you can touch the soil, that you can feel how it feels, initially, CPT is not necessarily the right methodology. Although you can take samples with CPT, you first do then your sounding, and then after that you are using a different dummy cone, and you can take samples with the CPT system as well. And finally, no system is perfect. Because CPT does not necessarily get samples, that you can put at analyze in a lab. Quite often what people would do is you take a single boring on a job site, near a location where you've done a CPT sounding and use that information to calibrate the results. So yeah, they are coming back to your question, Kevin. How do they work? Well, they're similar. They're both geotechnical site investigation methods. There are some major differences though, and as always, the more information, the better. If you combine the two, you might even get a calibrated CPT sounding so that the results that we get when we indicate this is the type of soil that, based on the CPT soundings there, yeah, you can get it confirmed in a boring, so that means you might have more confidence in those results. Does that kind of answer your question?
Yes, yes, thank you.
You want to follow up on this, or do you want to go to the next question?
Let's go on to the next question.
Okay.
So on a construction site, we have, it's constant. There's always something that comes up, something that was unforeseen, not encountered, not in the original bid. How can CPT benefit my construction site?
Okay. First of all, I think the big benefit is that it provides much more data. And what I mean by that is that when you do CPT, you get a continuous profile. And the CPT cone records at every centimeter or 0.4 of an inch. So you get a continuous profile as you go down. Whereas SPT, you get a point every 2.5 or every 5 feet, or if you do geotechnical boring, you may not get a continuous sample. If you do get a continuous sample, then obviously you have some information there as well. But if you, as I mentioned before, if you take those samples, you don't necessarily have the data right then and there. You need to analyze them in the lab. And as you were mentioning, Kevin, if things change on the job site, if something unforeseen comes up, by getting a CPT truck out there, by the time he comes out there, 25 minutes later, you will have your answers. But there's a much more important thing that I think that needs to be considered or taken into account. Your construction site is there, but it is not there at the moment that you start only when you come to the construction site for your construction. Quite often we talk about a construction site, but it really is the project site. The project site is something that is different than the construction site. And what I mean by that is that when you are thinking about a project, quite often there are initially done some borings, maybe 2 or 3 on the whole site, well before there is a different or a definite plan on what the plot plan is going to be, what the site plan is going to be, where the major foundations are going to be. And the beauty of CPT, because it is so fast, what I would do is do CPT at different times at the project site. Initially for your initial design to get a rough idea of what the soil is all about. But then once the plot plan is finalized, when the site plan is finalized, go back to that site before the site has become the construction site, before construction has started, to see what the soil conditions are at the places where you have your major foundations, so that you can optimize those foundations. And if you allow time in the schedule for that, that will help you. And then finally, during construction, when it is truly a construction site, if some unforeseen things come up, you're driving a pile and suddenly the blow count is going to be much higher than expected, you can again push a cone nearby, get an answer in 25 minutes, and you don't have to wait weeks or days to find out what the answer is. You have an information, some additional information, a response right then and there to get a better understanding of what's going on the site for unforeseen situations. So those are kind of some of the differences or the things that how you can benefit, how the construction site can benefit, how your project site can benefit when you use CPT.
So Gerald, let me ask you this. So you would suggest that the project site, so you do your initial geotechnical investigation. Usually it's still a very overgrown, very wooded lot that somebody decided, hey, I'm going to put a building here. So they go out originally with a geotechnical investigation, they drill, they do borings, they get an initial plan. So after the plan is kind of in place, so you would suggest that after the site grading has been done and they know where they're going to lay out a building, things of that nature, you would suggest then going back in with a CPT and doing some pushes in places that you know foundation drilling is going to be performed?
Yes, when I was director of engineering of a large turnkey contracting firm, I always made sure that between the moment that the plot plan was finalized, there was sufficient time for a CPT truck to go out to the job site to take additional, get additional information at the locations where the major foundations were going to be, right, where you have most of your concrete go into the ground, so that we then could optimize the foundations based on the results at the very location where that foundation had to be. And as long as you build it into your schedule, the cost to go out again to the job site to get additional site investigation data is more than offset by the savings that you'll get in your foundation. Sometimes, though, you may get a negative surprise. Sometimes it means that what you had assumed is not adequate and you need to put more concrete in the ground or more steel in the ground. But then, better knowing that in advance, because if you only find out during the execution, you're going to have all kinds of delays and all kinds of problems. So yes, by the time the plot plan is finalized, go back out to the job site and get additional site investigation data, and I would use CPT for that.
Okay, excellent.
Anything else?
So with that being said, excuse me, with that being said, how can the CPT change the bid or planning procedure? I think we touched on that a little bit there at the end of the last slide.
Yes, we did, and that's when you. I don't think that this question was necessarily your next question in the list that you originally sent me, but I put it in here because it did indeed. It kind of flows. One of the nice things is that, as put it here, the last bullet item, make sure that your project execution schedule allows it to utilize CPT to optimize your foundations. But there are another couple of things that are important for people to remember. We started out by saying, how do geotechnical borings compare to CPT? And the reason for that is that most engineers here in North America are used to design and foundation based on data that they're getting from geotechnical borings. And what they do then is when they get CPT data, they convert that into N values and then all kinds of other parameters, and then go from there. What we're suggesting is to use the CPT data as direct inputs in the design methods. And the Minnesota DOT put out a manual about a year and a half ago or so, an excellent manual to describe how you can do that. And I refer to that manual not because that's the only manual that's around in Europe and many places. It has been done for a long time that way. But here in North America, we're still having to get used to that. But MnDOT has shown that it can be done. So use it as a direct input into your design method. That may mean that you have to do some initial training and additional training of your engineering staff, put your planning to make sure that they can do that. But that is something that is to me very, very useful. But most importantly, in your overall design, if you just take a sample every 5 feet or something like that, and then get an indication with SPT values, you don't have necessarily a continuous profile. And I think the biggest issue that we as geotechnical engineers or as construction engineers have to deal with is site variability. And what I mean by that is that when you look at everything, we know the concrete, the quality of the concrete, we can design it the way we want it, we can order the steel to a certain grade. That's all within our control. But the soil is not within our control. We have the soil as when we get a certain location, that is what we have to deal with. And the more information we have, the better it is. And with CPT, you get a more extensive amount of information. Therefore, you know more about the job site. Therefore, site variability is less of an unknown. And therefore, it allows you to, in my opinion, to put a better project together. So those are kind of the things that when you talk about your planning process, make sure that your engineers know how to design directly from CPT data, allowing your project schedule that you can come back and do CPT once your plot plan is final. And also, because you have a better soil model, more complete soil model, you have to deal less with site variability, which hopefully will mean that your whole construction process will have less surprises, and less surprises means a shorter schedule, and therefore your overall duration of your construction phase will be shorter. So that's kind of the answer to this question, Kevin.
Excellent. So again, like I said, we touched on it a little bit in the other slides, but when should the CPT testing be done?
Right. And as you said, it was kind of interesting when I got your list of questions, that some of these things started to all fit together in the puzzle, and you see that now yourself as well. Yeah, obviously, CPT test, we can be very brief about this whole thing. Do it initially, possibly with the soil boring for calibration. Then, when the plot plan has been finalized, before you do your detailed foundation design, at least for your major foundations, to save concrete, to save steel, and then finally during construction, if unexpected situations arise. And don't be surprised that that happens quite a bit. When I come to a job site, and I would ask people, okay, is everything going smoothly? And the answer is always, yeah, because they never want, and most of the time I'm there on behalf of a client, they never want to say that things are not going well. So yeah, everything is fine. I say, well, is everything going to plan? Oh, yes, sir, everything is going fine. Has anything unexpected happened? And then you start seeing that people start to think, well, how honest am I going to get going to be to this guy? And then quite often things are coming, well, yeah, this happened and that happened, and we really don't know what the situation is and why it happened. Blow counts suddenly go up higher than expected, sometimes a lot lower than expected. And those unexpected situations could easily turn into something much more serious. And that is why it's nice if you can, when you have an unexpected situation, that you get with the CPT some additional soil investigation so that you know what has happened. Because let's face it, as I said before, there is site variability. The soil is not constant over your job site, however small a job may be. So yeah, make use of that and don't just ignore unexpected situations because they could turn into something much more serious.
Excellent.
I guess you want to go to the next question?
Yes.
What do you have in mind here?
So that's a really good question. Yeah, that's a good question. I know that some job sites are really tight. Some job sites are really.
I lost your audio, Kevin.
Sorry, Gerald, I lost you there for a second. Would you actually have to shut down the construction on a site?
No, you don't. It depends, of course, how big your construction site is. But as I put it out in the way in here, you just need to be out of the way. Most of the time when CPT is being done and you come with a truck, a CPT truck or a CPT crawler, the crawler needs to go, or the truck needs to obviously go to the location where you want your CPT to be done. And you cannot be then at that very location. But that is just there. The structure will be sit there for about, say, half an hour, and then he's gone again. So during that time, you just need to be out of the way. There's no reason to shut down the construction site. except for, and in some instances, when you do its particular type of CPT. And one of the, we've mostly covered so far standard CPT, where you push a cone in the ground, and then you take your tip resistance, your sleeve friction, and your pore pressure. But as I mentioned in one of the previous seminars, you can also do seismic CPT. And with seismic CPT, we basically check how or get an additional parameter of the soil, which is especially useful in areas where you have potential earthquake activity. One of the things that the building code in North America is calling for is that you need to get an average value of the shear wave velocity over the top 30 meters or the top 100 feet. And if you do that seismic CPT, then it may be necessary to stop certain type of activities near a CPT location. Why is that? If you have a heavy dozer doing its work near where you're doing your seismic CPT, it will introduce vibrations in the soil that could be misinterpreted as seismic waves during the seismic CPT. Normally you just create those source waves with a hammer and a plate, but if you have heavy equipment going nearby, say within the next, within 30, 50, 75 feet or something like that, it may create a problem. So that is something that needs to be done or needs to be taken care of, and that you, in that time, you stop those activities. But other than that, there's no reason to stop any of the activities. And then I see that I left a final sentence here on this slide. What you see here, once the plot plan has been finalized before foundation design, you can ignore that. That's my mistake. That has nothing to do with this question. It's just a carryover from the previous question. So no reason to shut down the construction site. That's the bottom line.
Okay. Well, would you recommend using the seismic CPT cone as opposed to a regular CPT cone?
Well, sometimes it's not a question of recommending it. The building code has, well, it's quite a few standards, require, if you are in certain activities where there's earthquake activity, that you have to calculate what the shear wave velocity is over the top 100 feet or 30 meters. And then you have to use a seismic cone. Not necessarily for every single sounding, and most of the time you do some soundings seismic CPT, and you then can incorporate it in your overall schedule for the day, that you do it at a time that it's really not that inconvenient. On a job site not so long ago where we had to do something like this, we had to be there pretty much all day for regular CPT. We knew we had to do 2 seismic tests. We decided to do it during the lunch hour when everything was shut down anyhow. We did our seismic CPT, and there was no inconvenience for anybody. Seismic CPT gets you additional information, which is useful, but it's not necessarily necessary on every single job. So I would not necessarily say that I recommend to do seismic CPT on every single project.
Okay, thank you. So safety is a big factor on these construction sites. The less people in the way, the better. What are some of the safety aspects for performing the CPT on a construction site?
Yeah, safety is important, and maybe we should even have put this question first, because safety is very important and needs to be taken into account. You see 5 bullet items, and they're all common sense. You basically are dealing with, quite often, with a truck or a crawler that has a pushing capacity of about 20 tons. So it means that the gross vehicle weight of the units is something like 46,000 pounds. That's heavy equipment. So that means that you need to have a plan how to move that to the various test locations on your site. And it may require a suitable working platform. But it also means that you need to make sure that when you move the equipment from test location to test location, that you need to pay attention. And especially on a job site where there's a lot of noise, make sure that you have safety people there to make sure that the equipment moves to those locations in a safe manner. Most importantly, though, when you push a cone into the ground, and whether you do it with a cone or with a sampler, but when you push anything in the ground or when you start digging, make sure that you know where underground services are. It was not too long ago here in the area, had nothing to do with CPT, but they were pushing something in the ground. They hit a gas line, and the results are pretty catastrophic. Underground services are not necessarily where they're being shown on the drawings. This has nothing to do with CPT. This is general construction, site construction issues. Underground services are probably the most risky issue that we're dealing with. So make sure that you know where they are, get them tracked before you start doing stuff, and don't necessarily try to come too close. There's absolutely no reason that you need to do a sounding within 6 inches from an underground surface. You might as well go a few feet over. Sometimes you have people that say, well, my major foundation is sitting right here. Then my question is, if your major foundation is going to be there, why is your underground surface still there? Then you need to move your underground surfaces as well. So underground surfaces, pay attention to that. And then finally, and that's something that we need to keep in mind as well, when you have landfills or contaminated sites, make sure that you address potential hazards. When you bring your cone back out of the ground, the rods may be contaminated with that soil. You have now soil that comes through the surface, so make sure that you take proper care of that, and that you at least are prepared for that. So that's kind of that.
Thank you, everyone.